Hello everyone, welcome to Zintelligence. If you have watched my previous 3 videos, I believe that you will have no problems with understanding multiplication principle and addition principle and how do you apply both of them in a specific question. Those 2 counting principles are the 2 most basic and fundamental ideas of problem solving in combinatorics. However, for a lot of questions you're gonna see, if you just know those 2 counting principles, sometimes your process is gonna be so long. For example, for some questions, if you wanna use multiplication principle, you will need to have 50 steps for just one question. Clearly, that's not efficient enough for our exam. So we must need some other techniques that can really speed up our process. So today, I'm gonna introduce to you 3 types of new operation you might never seen that before, which can work pretty well in a counting question. And the first one is factorial. It looks like an exclamation mark in English. But in math, we have a different name. We call that factorial. And our second friend here is permutation. We have 2 numbers n and r, and we put a symbol p in the middle of the 2 numbers. And the last guy here is called combination. It looks similar as permutation, but it just uses c here instead of p. But sometimes we'll write this in another more common way, which you have bracket and you put an n, r, these 2 numbers in the middle. So this one is called combination. So for us, in order to have a more comprehensive understanding on these 3 notations, we need to learn them from 2 aspects. First, we have to understand their algebraic meaning. Okay, I know it sounds a little bit advanced, but here, basically what I'm saying is you need to know how to calculate them. So this time, you're gonna treat them just as normal operations like addition, subtraction, multiplication, and division, or a to the power of b. But beyond that, we have to know their combinatorial meaning as well. So, oh my god, what does that mean? Okay, that basically means you need to know how to apply each of them in a specific counting question. So, in today's class, we're just gonna focus on their algebraic meaning, which means we just need to know how do we calculate their value. For how do we use them in a counting question, we will talk about this in the next video. So let's begin with the first one, which is a cute explanation sign. We call that factorial in math. You will always see this notation accompanied with a number, like 2 factorial or 3 factorial. So to write a correct factorial expression, first you need to have a non-negative integer n, which means we can also say that n is a natural number. So remember that in IB, natural number does include 0. Okay, and once we have the number n, I just need to add a little factorial sign on the upper right corner of this integer. Okay, so here is a factorial notation. And to calculate a number's factorial, we need to do some casework here. Because depends on different values of n, you're gonna have different ways to calculate factorial. So case 1, if n is greater than 0, basically saying that n is a positive integer. For example, how do we calculate 5 factorial? It's actually easy. So 5 factorial will simply equals to 5 times 4 times 3 times 2 times 1. Did you find a pattern? Yes, you're right. We're multiplying the number from 5. And each time for the next factor, you're going to minus 1. So the one after 5 will be 4. And the one after 4 will be 4 minus 1, which is 3. So of course, I have 2, and the last one should be 1. And you're stopping at 1. So another example, if we have 7's factorial, according to the pattern we just discovered, that will be 7 times 6 times. So in general, if we have a positive integer n, its factorial will be n times 1 less, n minus 1, and n minus 2, n minus 3, until 1. But remember that our n is a natural number. A natural number is 0, 1, 2, 3, and dot dot dot. We just talked about the case when n is greater than 0. But what if n is 0? So now, let's take a look at this case. If n is 0, so we have 0 factorial. If we try to use a rule we just explored, you will see that 0 factorial will be 0 times -1 times -2, but it keeps decreasing, and it will never reach the number 1. So for this case, 8 is special. And a lot of people will guess that 0 factorial is just 0. However, the reality is 8 equals to 1. That sounds a bit ridiculous. Why is 1? Okay, for now, you don't really have to know why it's 1. The proof is not required in IB, so I will say just remember that. I find a similarity when you calculate power, right? Let's say if you have 2 to the power of 0, the answer will be 1, not 0. So sometimes math is weird, but it will never cheat you, so just believe in it. I know someone want to ask, okay, we talked about non-negative integer, but what about -1 factorial? What about pi factorial? Oh my god, don't be that curious. They are actually defined, but not covered in IB, so you just assume that they don't exist. Here comes our second guest of today, the permutation notation. So let's look at a permutation expression first. We need to have two numbers first. Let's call them n and r. And then we just put a capitalized P in the middle to show that n and r are under permutation operation. So an example will be if we have 3 and 2, these two numbers, and we put a big P in the middle to indicate that this is permutation operation. But more importantly, we need to understand how to calculate the permutation expression. So the formula of permutation is given in our formula booklet. In your booklet, you can find this formula. nPr equals to n factorial over n minus r factorial. Hopefully you still remember how to calculate factorial notation. But for nPr, this notation, there is some restrictions on the number n and the number r. Remember that when we talked about factorial, only natural number can undergo factorial operation. So here we have n factorial. That means n has to be a natural number. And on the bottom, we have n minus r factorial. So in order to keep n minus r a natural number, which means a non-negative integer, the value of r has to be smaller or equal to the value of n in order to keep n minus r positive, non-negative. And there is still a special restriction on r, which r has to be a natural number too. So now, let's write down all the restrictions we have. First, n is a natural number. And second, r has to be a natural number too. And remember, n is greater or equal to r. Okay, now let's have an example to strengthen our impression on this formula. So let's say if n is 5, and r, let's say, is 2. So I'm gonna have 5p2. According to the formula, I'm gonna have a fraction, which the numerator will be n factorial, which is 5 factorial, and the denominator will be 5 minus 2 factorial, which is basically 5 factorial over 3 factorial. So to calculate this thing, you can just calculate the numerator and denominator separately and divide them. But there is a much faster and easier way to do this. So first of all, let's just expand the factorial notation. On the top, it's just 5 times 4 times 3 times 2 times 1. And my denominator will be 3 times 2 times 1. Don't forget that this is a fraction. So we surprisingly find that we can just cancel all these two things. So my answer will just be 20. Let's see another special example here. Let's say we have 6p0 this time. That looks special, but let's see how do we calculate that. Since that formula is our only way to calculate permutation, so I will just use that formula again here. If you look at the formula, you will get 6 factorial over 6 minus 0 factorial, which is basically 6 factorial over 6 factorial gives me 1 as the answer. Our last operation of today. Its name is combination. So usually, a combination expression can be written in two ways. Both of them are accepted by IB, and you can choose the one you like. The first way to write it is very similar as how you write permutation, which you have two natural number n and r first, and this time you put a capitalized letter C in the middle. So it's written like nCr. That's the first way to write combination notation. And we can also use the bracket notation, which we have a big bracket, and we put a number n in the top of the bracket and r in the bottom. So you can see that it looks the same as a two-dimensional vector. But in this chapter, it means combination. And now let's look at the formula provided in your booklet for nCr. Here is a formula for nCr, which we notice that it looks very similar as the formula nPr we just learned. Let's take a review for the formula of nPr. We know that nPr equals to n factorial over n minus r factorial. And we can see this part, it looks exactly the same as this part. So that means we can separate the two parts, which will be n factorial over n minus r factorial times 1 over r factorial. We know this is nPr. So nCr just equals to nPr times 1 over r factorial, which is just divide by r factorial. So here, we actually have two formulas for nCr. So the first formula given in the booklet is used more frequently. But for some questions, if you know the second formula is more helpful. And one more point, you should know that only the first formula is given on your booklet. The second formula is not given in your booklet, but I still suggest you to memorize this one. Okay, now let's have some examples. In this example, we are calculating 3C2, which we can also pronounce that as 3 choose 2. So why do you call that 3 choose 2? Well, we're going to talk about that in the next video. Okay, so now let's just focus on how to calculate it. According to the first formula, it will just be 3 factorial over 3 minus 2 factorial times 2 factorial, which will just be 3 factorial over 1 factorial times 2 factorial. So to calculate this thing, we can use the same idea as what we did in this example. So we can expand the factorial and reduce the fraction. Okay, so now let's just expand the factorial notation. So 3 factorial will be 3 times 2 times 1, which is 6. For the denominator, we know that 1 factorial is 1, 2 factorial is just 2. 1 times 2 equals to 2. So the final answer will just be 3. Of course, we can use the other notation. For example, we can have 5 choose 2 this time. So we put a 5 and 2 inside the bracket. So we know this is 5 choose 2. For the bracket notation, we usually say 5 choose 2 instead of 5C2. Just simply because there's no C in this notation, right? But the way to calculate it is exactly the same. So I want you to pause the video and see if you get a correct answer. So hopefully you get a final answer 10. Okay, one last thing about nCr I want to mention, which is restrictions on the number n and r. The restriction is pretty easy. It's exactly the same as nPr, which means first, n and r has to be natural number. Again, in IB, natural number does include 0. So it'll be 0, 1, 2, 3, and da-da-da. And also, we need to know that n is greater or equal to r. Okay, we've done all the 3 notations, and now it's a time for us to do the real things. In the first question, we are asked to prove this identity involves factorial notation. For most of the questions involves factorial notation, we always have 2 ideas to deal with them. So, our first way will be, for the questions involves fraction, we can always expand the factorial notation into the multiplication expression and reduce a fraction. Just like the example we did. Remember, we did a question, it's like 5 factorial over 3 factorial when we're doing nPr, right? So what we did is we know that 5 factorial is just 5 times 4 times 3 times 2 times 1. And 3 factorial will be 3 times 2 times 1. And something good about fraction is I can eliminate the common part of the numerator and denominator. So here, this 3 times 2 times 1, I can just cross it out. Which the answer will just be 5 times 4, which is 20. So our method 1 works pretty well if we see factorials in both top and bottom in a fraction. And we have our second method. So sometimes the questions involve the sum or the difference of 2 factorials. In those kind of situations, I can always common factor out something. For example, if I have 7 factorial plus 5 factorial. Since we know that factorial is just a whole bunch of multiplications, I'm always welcome to write factorial as the multiplication form. So 7 factorial will be 7 times 6 times 5 times
4 times 3 times 2 times 1.
And same thing for 5 factorial, which equals to... And we notice that for both of the two parts, they have the common part 5 times 4 times 3 times 2 times 1. Of course, I can factor out that. And we notice that the common factor is just 5 factorial. And what's in the bracket is easy to compute, which is just 43. So our method 2, which is common factor, works pretty well if we're adding or subtracting 2 factorials. Okay, now let's keep these 2 methods in mind and try to solve this question. In this question, we're proving this identity, which we're gonna work either from left side or the right side. Notice that in the right side, we just have a factorial. But in the left side, we have a pretty ugly fraction. So we need to clear the left side's fraction somehow. If you look at the numerator of the left side, you can see that we are adding 2 factorials together. Does that remind you something? Yes, that's our method 2. We can common factor out something. So first of all, let's try to expand the factorial first. n plus 2 factorial will just be n plus 2 times n plus 1 times ... and the last one should be 1. And we have our n plus 1 factorial, which is the same thing. We notice that both of them have the common part n plus 1 times n and until 1, which is basically n plus 1 factorial. So I can definitely factor out this thing first. So that means our left side will just be, for the numerator, it's just n plus 1 factorial times, so we have n plus 2, which is here. And the second part will just be 1. And don't forget our denominator, which should remain the same. And of course, I know that this part is just n plus 3. Which can be cancelled out with the denominator. So our left side will just be n plus 1 factorial, which equals to the right side. So this question is cute. Here is our second example of today. In this question, we are also proving an identity. And we can see that both left side and the right side of the identity are combination operation. This is not an operation we're super familiar with, because we just learned that like 10 minutes ago. And unlike addition or multiplication or division, we learned a lot of operation rules for them. For combination, we almost don't know any property about it. So to deal with the operation like nCr or nPr, the best way we can do is just to use their formula and convert them into the operation we are more familiar with. So let's take a review for the combination formula, which n choose r equals to n factorial over n minus r's factorial times r factorial. Okay, so now let's just use the formula and convert both left side and right side into the fraction form. Let's look at the left side first. So it's just n choose r, right? So it's exactly the same as the formula. Okay, and in our right side, let's just use the formula again. So on the numerator will still be n factorial, and the denominator this time will be n minus r's factorial. because this time it's n choose n minus r. And we also need to multiply by n minus r's factorial. Clearly, the right-hand side can be further simplified. If we take out the bracket of this part, I will get n minus n plus r. The two n's are cancelled out, which simply just gave me r. So my right side will be n factorial over r factorial times n minus r's factorial. And we surprisingly find that this is exactly the same as the left side, which means the question is solved. Think our first two examples are too easy? Well, they were just warm-ups. Here is the real things. Our third example of today is a very typical IB-style question, which you're likely to see a similar level question on your exam. So, I hope you can pause the video and try the question yourself first, and don't cry if you can't solve it. Okay, so let's look at it together. In this question, we're solving a very special equation. In this equation, it involves combinatorial operations. That's something we've never seen before. But don't be scared. Remember that every time we see nCr or nPr, this kind of operations we're not familiar with, we can just apply their formulas to convert them into the fraction form, which we have more ways to deal with. If you still remember the formula, the left side will be x factorial over x minus 5's factorial. And now it's the right side. We have 56, we just copy that. And we have x factorial over 7 factorial times x minus 7's factorial. It still doesn't look nice, but at least we have something we can do here. Notice that there is an x factorial in both left and the right side. Clearly, x factorial is not 0. So of course, I can just divide by x factorial for both sides. Then let's see what we have here. In the left side, that will be 1 over x minus 5's factorial. And the right side will be 56 over these massive things. Notice that in both left and the right side, we have a fraction. So very naturally, I want to clear the fraction. So next, I will just cross-multiply them and clear the fraction. So let's see what we have here. We have 7 factorial times x minus 7's factorial times 1 equals to 56 times x minus 5's factorial. On the left side, we have the 7 factorial, which of course we can calculate it. So if you try it, that's not a crazy large number. It's just 50/40 if you calculate it correctly. So how do we do next? We are solving for x. So maybe one thing we can do is we can move everything contains x in one side. And of course, I can move the 56 to the left side. So if you calculate 54 divided by 56, I hope you will get 90. Oh, wait a minute. Look at the right side. It's a fraction with factorial on both top and bottom. Remember that first method to deal with factorial I talked about? If you don't remember, go back to the first example and see. You should know that every time we see this kind of thing, we should expand the factorial. And we know that there will be a lot of things to be cancelled out. Let's try it here. On the top, I should have x minus 5 times x minus 6, one less, right? And x minus 7, x minus 8, and dot dot dot. The last one should be 1. And on the denominator, I will start from x minus 7 and x minus 8, one less, and x minus 9 until 1. And the left side is still 90. Now, I'm giving you 3 seconds, and let's see if you can find out what will be cancelled out. The correct answer is all of these parts are cancelled out, and the denominator is all gone. So, the equation will become a very simple quadratic equation, which I have 90 equals to Let's expand the right side. You will get x squared minus 5 minus 6x. So that's minus 11x and plus 30. Of course, if you rearrange the equation, you're going to get x squared minus 11x minus 60 equals to 0. At this point, you shouldn't be struggling with solving the quadratic equation, right? So if you factor the right side, it will get x plus 4 times x minus 15, right? So that means I'm going to get two values for x, which the first solution is x equals to negative 4 and x equals to 15. So if the question down, if you stop here, unfortunately, you're going to lose like 2 points. You should always keep that in mind that for an equation with nCr or nPr, there is a very common trick. Look at where our x is located. We have x, choose 7 here. So that means x has to be a natural number first. And there's another one. We know that x has to be greater or equal to the bottom number 7. Same thing for the left side here. We have x p5, so that means x has to be greater or equal to 5. But we know that x is greater or equal to 7 is a stronger statement. So we don't actually need that x is greater or equal to 5, that statement. With this restriction, let's look back to the solutions we just found. Clearly, x1 does not work, because it's not even a natural number. x2, it is a natural number that's greater or equal to 7. So our only answer will be x equals to 15. Okay, that's all for the third example of today. If you have no problem with it, you are a graduate from this video, which is the algebraic meaning of the combinatorial operations. Okay, and I guess that's all for this video. And one last thing. I heard that everyone who subscribed this video channel got a 7 in their IB exam. So, what are you waiting for?